Clear? Now, in continuation to what we have discussed a few days back about surface tension, now we take something more. We are now going to take up what is meant by what are the factors which affect the surface tension. What are the factors which affect the surface tension? Uh, Let us view. Yeah, here is a chart which shows the variation in surface tension of a liquid. Uh, there are certain primary factors as well as the secondary factors. Now let us see what are the primary factors and what are the secondary factors. These affect the surface tension of a liquid. Temperature, very important. Temperature is a major controller of the surface tension of a liquid, any liquid. And we find that higher the temperature, lower is the surface tension. Lesser the temperature, greater is the surface tension. Why it is like this, we are going to discuss. Now, we shall discuss a little later, but then what are the other primary factors which affect the surface tension? You must know the result, the outcome of these factors. Presence of impurities. It may be a soluble impurity, it may be an insoluble impurity, or less soluble or sparingly soluble impurities. If it is a soluble impurity, in case of water, it may be soluble solutes like sugar, water, salt, lemons, etc. They increase the surface tension. Surface tension is increased by those impurities which dissolve in the liquid. If less soluble impurities are there, or even if insoluble impurities are there, the surface tension decreases. Why? We are going to take it up in the next slide. Then secondary factors are also there. That is about the nature of the liquid, what type of liquid is there. Okay. Environmental effects and also the addition of emulsifiers. Nature of the liquid. Of course, by nature we mean the molecular structure. It may be water, it may be alcohol, it may be any other liquid. Every liquid has got its own composition, a structure, molecular structure, and therefore this is something which cannot be varied for a particular surface tension of a definite liquid. Environmental effect may be contaminants like dust, grease, oil, etc., which are present at the surface of the liquid. They gradually decrease the surface tension. Indeed. Then addition of emulsifiers. Emulsifiers are the substances which are added between two immiscible liquids. Emulsifier disrupt the cohesive forces between water molecule and at the surface, thereby lowering the surface tension. Emulsifiers, cohesive surfaces, cohesive forces. We have already discussed about what is meant by cohesive forces. Cohesive forces means the force of attraction, attractive forces, interparticle attractive forces, which cause them to come together and shorten the distance at the surface. Okay, then surface tension of a liquid is an intensive property. Intensive property means the physical property which depends upon the temperature, density, melting point, etc. Its molecular interaction and bonding composition. Indeed. Surface tension of a liquid is an intensive property, means its molecular interaction, bonding, and the composition. Now, earlier I had told you why the surface tension is affected by variation in temperature. Indeed. A rise in temperature of the liquid amounts to providing extra energy to the molecules which are present at the surface or even in the bulk of the liquid. That means the energy supplied to liquid molecules increases their thermal energy. The molecules become more energetic kinetically. Thereby intermolecular forces becomes weak, and weaker the intermolecular system, therefore intermolecular distances increase, and as the molecular distance, molecule to molecule distances increase, the surface tension will definitely be decreased. The tension, we know that tension is simply because of the cohesive forces. These molecules coalesce together. The surface tension is liquid is lower. Same thing here in form of a chart. Liquid at higher temperature increases thermal energy, intermolecular forces get weaker, cause increase interparticle distance, reduces the cohesive forces between the liquid molecules and liquid, and the elasticity of the film decreases, just lowering the surface tension of the liquid. Now, let us see what is there. How is surface tension of a liquid affected by change in temperature? How this is affected? Two ways are there. There may be a greater change in temperature or a little change in temperature. If the temperature variation is not much, of course the factor is lesser the temperature, greater the surface tension, higher the temperature, lower the surface tension. The general trend in an increase in temperature lowers the surface tension of a liquid. And if you plot surface tension with temperature, surface tension, here is a graph, we find that there is a straight line with certain slope. But then this occurs only when there is a little change in temperature, not much sudden change in temperature is not there, then this will happen. And a mathematical relation can be given like this: Tt, this is tension, T means capital T means tension at temperature T. T naught is the tension at 0 degrees Celsius, and alpha is the coefficient, temperature coefficient. Because on simplification, if you simplify it, simply a mathematical simplification, you get this: Tt is equal to T naught minus T naught alpha T. From this we can calculate alpha, and we find that the plot, if you plot it, a little change in variation results into a straight line having a negative slope, and we can very easily calculate the temperature surface tension with this graph. Now, what will happen when there is a large temperature difference? Of course, contrary to what we have taken up earlier, if you plot surface tension against temperature, we don't find a straight line. We get a curve, isn't it? Till a critical temperature is attained. Large range of temperature difference, lowering of surface tension of a liquid is greater till the liquid attains a critical temperature. Critical temperature is the temperature where the liquid and gaseous phase are indistinguishable. You cannot distinguish between liquid phase and the gaseous phase. Temperature at which gas cannot be liquefied, even by applying any extent of pressure. So, at critical temperature, the surface tension becomes zero. Naturally, it is quite obvious that the liquid loses its existence, and it is very difficult to find it out. Okay, we stop here. We shall have something more about surface tension a little in another video or in another presentation. Thank you. Wish you all the best.